Okay, so welcome back. This is part 5 in our series where we show you how to develop some very simple circuitry that will connect to your Arduino and allow you to monitor in real time the frequency of the wall outlet voltage provided to you by your power company. What we're going to do in this video is we're going to develop a very simple C# application, or you can do it in any programming language, but we're going to use C# here. It's a very simple application. What's going to do is going to allow you can see it right here, because every half a second it's going to give updates on the actual power line frequency. Now, I encourage you to look at the previous videos in this series. We talked about what this frequency means, and for a power company utility, it's really a very important number. And we talked about how it indicates the status of the power system, and that the power system here in the US is generally a very large grid connected across many states or large portions of the United States, all tied together with many generators and millions of customers. And this frequency is an indication of how that whole system of generators and loads is doing. And we gave an example of how, for example, if your power system gets overloaded, too many customers and not enough generation, it's like your car driving up a hill. It's going to slow down. With the power company, that slowdown is going to be indicated by a slowdown in the frequency, and you're going to get a lower frequency below 60 hertz. And likewise, if you've got more generation than load, the generators are going to speed up, just like your car going down a hill. You're going to get a high frequency. We also talked about how that frequency is very strictly monitored, and there are government regulations that require the power company to maintain this 60 hertz for a number of reasons. Therefore, if it gets outside that normal range, you can be pretty well assured that there's some serious problems on the power grid across, like I say, maybe many states in the US. So it's an interesting thing to monitor and see when we've got some major grid disturbances. So what we did in the previous videos, we explained about the frequency, like I say. We also developed a couple circuits, very simple circuits. This circuit you see here in LT Spice is one of the circuits that we developed, and we're going to use in this particular video to develop this C# application. And as you can see, we explained it in the previous video. I'll go through it real quick. You've got the wall outlet voltage coming into a transformer and a little bit of circuitry here, and it goes into an optocoupler. And the output of this is going to be a square wave that is proportional to the 60 hertz sine wave. And that square wave is going to run into the Arduino, and the Arduino is going to set a timer. When it sees the positive front of the square wave, it's going to start a timer, and then it's going to time until it sees the next positive front, which indicates one cycle, and it's going to calculate the frequency from that, fit it to your computer. And as you can see here, we're just grabbing that data from the Arduino and updating this C# application. Now, in the previous video, we used Excel Data Streamer to grab this data. In this video, we're going to make something more permanent, which is the C# application. Now, the functionality of this, you can see, is pretty straightforward. We're going to grab the data, in this case every half second, and display it here on the application. We've also got some other features. You can see down here we are keeping track of the minimum and maximum frequency we've seen since this application has started. And we also have this reset button, which you can see if I press it, it resets these minimum and maximum values. One other feature this is going to have is if the frequency, the actual frequency, gets outside the normal range as defined by the government requirements, this application is going to start saving each successive reading to a CSV file. So if the frequency gets out and there's some sort of disturbance, an abnormal disturbance, we're going to keep track of the frequencies over a period of time in a CSV file, and then we can bring that into Excel or whatever, and we can chart it and do what we want with it. So now here is the Arduino sketch we developed in the previous videos. I'm not going to go through this. The only thing I want to mention is the only thing I changed for the C# application was I changed the updating time to every half second. You can see I've got this delay here. Previously it was 1,000 milliseconds or 1 second. I've sped that up a little bit so we get updates every half a second. We'll talk about the reason for that, but this is the sketch. There's no change from the previous videos. So now let's think about some of the functions we're going to want to include in our C# application for this frequency meter. Like we said, we just have some labels here that are displaying, in this case, real-time updates of the frequency. And then we have two more labels that are taking the minimum and maximum frequency and updating that as the minimum and maximums change. And we've got this reset button, and there's also a hidden label up here that will tell us if the frequency gets outside the normal range and we're starting to save the readings to a file because there's some sort of frequency disturbance. We'll get a label out here that says there was a disturbance and give us the date and time that this occurred, so we can know hey, we had a disturbance. So that's the basic functionality of this. So let's go into the C# application and see how we can develop it. Okay, so here we are in our C# Windows Forms application. We're in Visual Studio for this frequency meter right here. It's really a very straightforward and simple application. I don't have any separate classes, or I'm not using anything fancy. It's just this one Windows form, and you can see all I've got is this design for this form, and that's about it. I've got my standard format where I've got my documentation, my to-do list, which is now empty, my initialize, where we just initialize some variables. We'll talk about those. My form one that just gets everything set up, and then I've got my methods and event handlers. And as you can imagine, this is going to be pretty much driven by an event handler, which is going to update this display, in our case, every half a second. And I've got one method. So let's take a look at this. First, I've only got a few using statements. System.io we're going to need for the COM port, and also because we're going to save data to a file if we get a disturbance. So we need that. System.threading.task. We're going to do a little async and await here to put our UI on a separate thread. And I've done videos before about async and await and parallel processing. We did a subnet scanner where we talk about async and await, and I encourage you to take a look at that. But what we're going to do here is we're going to have a separate async and await, a parallel task to grab the data from the COM port so it doesn't slow down the UI. And of course, we've got the windows.forms. So let's take a brief look. I've got the documentation here, just some notes. One thing I put here, the important consideration with this app is to make sure you get fast updates, even if they might have some inherent noise. Now, we showed in the previous videos where we developed this, our circuits were not all that clean. You get some bouncing around, some noise in the readings, and that's not necessarily a bad thing. We may not want to do any noise filtering in this application, data noise filtering, to clean up that noise, because if you think about it, it introduces a time delay. Say you have one reading of 60 hertz and the next reading is 59.9. If you have some filtering, it's not going to immediately replace the 60 hertz with the 59.9. It's going to give you some average in between those values. So if that 59.9 is a legitimate value, it's not going to show up for a few readings. That's kind of like a time delay. One of the things we're going to talk about is how we're going to clean up this noisy readings, and whether we want to do it in this application or save the raw data and bring it into Excel and then clean it up there. So that's something important to consider. Of course, this app has a system timer that reads the serial port every half a second. And it relies on the Arduino sending the actual measured frequency as a string. It'll look like 59.9, and it's going to send every half second. And that's the Arduino sketch we already talked about. There are no client-server requests. This application doesn't request data, it just receives it. So there's just a steady stream of values from the Arduino. It then converts the received frequency string to a double and keeps track of the max and min frequency like we showed, and writes those values to the UI labels. It also detects if the frequency is outside the user-specified over and under frequency ranges, and if so, automatically appends the time frequency values in CSV format to a file, and we'll talk about that. So that's basically all this does, and you can imagine it's pretty straightforward. Again, no to-do list. So let's look at the initialized variables we've got here. and it'll give us an idea of what we're going to be doing down in the application. So the first one is a Boolean, and that tells us if we got a legitimate reading when we did a read line from the COM port. If it was successful, we will say success equals false. If not, it timed out or something else happened, we didn't get a legitimate reading from the COM port. So if this success was false in our logic down here, we're not going to process the reading because it's probably a bad reading or an old reading. So this just tells us if we got a fresh, good reading from the COM port. The latest frequency value is a double called freak. And then we're going to keep track of the previous value, and we're going to initialize it as 60. We're going to show how we talked about some data filtering. I'm going to show you how to do a very simple data filter, like a low-pass filter, which you may or may not want to use. I'll just show you how to do it. And then we're going to have the frequency max and frequency min. We're going to start out with a max of 0, so any value is obviously going to be above that. And then the min is going to be a high value, and any value is going to be below that. We're going to have these under frequency and over frequency set points. We said in the first video that normally your frequency is probably not going to vary below 59.9 hertz here in the US or above 60.1. And if it does, there could be something going on. So these are the points at which we want to start saving data to a file because it's possible something bad is going on. And then we're setting up the string path, which is the path for the output CSV file, okay? And that's it for the initialize. So now that we've got the initializing, let's run over and take a look at our UI. And you can see here, we mentioned it's pretty straightforward. There's some labels and a button. But down here, you can notice what I did is I drag and dropped from the toolbox a serial port component, and we can go down here and see that under components we've got a serial port. So you can just drag and drop that onto your form, and then once you've got that you can select it. And over here on the right, I changed the name to the Arduino port, and you can set whatever settings you want. I defaulted the port name to COM3 because that's my standard port for this Arduino. You can change whatever else you want, but it's a very nice way to set everything up so you don't have to do it in code. I've also dropped a system timer from Toolbox and Timer. I drag and drop that on, and I can select it, and now I can change the interval to 500 milliseconds, and I can change the name if I want, but I didn't. So nice ways to set up these two, and if you double click on these, they will automatically generate the event handlers. So that's about it. We've got a button, we've got 4 labels. Also here I've added a group box. Just drag and drop the group box because it allows me to easily give a black background to the display. If you scroll up here, you can see the back color is black. But you don't need that, I just put that in. So now going back to this, we've got the Form 1, the standard initialized component. Here's my Arduino port that we just showed that I drag and drop the serial port. And I'm just saying open that port. And I'm setting a read timeout, which means that if it tries to read and it doesn't get a value within a second, it's going to give an error. And then I'm starting my system timer every half a second to go to the event handler and grab the data. All right, very simple Form 1 basic components. Now I've got one method here which is going to go out and grab the data from the serial port. Now you may notice I'm using asynchronous threading. I set this up as a separate method so that we can put this on a separate thread to get the data, and it doesn't slow down. You can see our UI is very responsive. So while we're grabbing, taking 1 second or half a second to grab data, we don't want to slow down the UI. So I've just got this one method we'll talk about. And as you can imagine, the event handlers are what does all the work. I've got the reset button, and we'll talk about that. But the timer one, the half a second update, is got this code here, and it's not really got too much to it, but we'll go through it. Also notice I have added async to this because in the threading, we're going to use this, we're going to call that method the asynchronous method to get the data. So I've got async, void, and the timer 1 tick. Again, I double-clicked on this timer and it automatically generated this event. First thing we want to do, every half second, we want to clear the buffer coming in from the Arduino port in case it's got any old data. So I said Arduino port, which is what I named it, discard the input buffer so that erases any old values. The next thing I'm going to do is try catch to try and grab the data using this method. Okay, this method up here. And again, it's an async method. So I'm going to say the freq, which is the latest frequency, get frequency async, and it's going to return a double. And we're going to await that, but go on and do the UI stuff. So let's go to that, and you can see again, I've got the async, and it's returning a double, but since it's asynchronous, it's a task of double. And here is the get frequency async. So the string from the read line, Arduino port, the read line is a string. It's a string of value like 59.9. And I am wrapping that in a task.run, and I'm awaiting that. And I did another video, like I mentioned, on async and await. I encourage you to look at that. Very simple way to just wait for this while you go off and do your UI stuff. So now I've got the string, like 59.9 string. Then I convert that to double, that frequency string, and return it. But we're returning as a task of double since this is asynchronous. And that's why we need to make the timer event handler asynchronous. Okay, so that's the method, very simple. So now we're going to try that, and we're awaiting that asynchronously. And if we have a successful read, and it doesn't time out or give some other problem, we will set that success boolean to true. That means, okay, we got a decent number, then we can go through and process it. If not, we're going to set success boolean equal to false, and you're going to see down here, all the rest of our code is wrapped in an if statement, and it only does it if success is true, all right? So the only thing left in this event handler is this if statement. So we've determined, we've grabbed our reading, and if we got a legitimate one, we've got a legitimate frequency. So now we're going to go into this if statement. The if statement only considers the legitimate frequencies and only if the latest COM port read line was successful. So if frequency is greater than, say, 40 hertz, I just picked that number, and it's less than 80 hertz, those are the values. You're probably not going to go outside that range. You can choose others if you want. And success equals true, we got a good reading, then we're going to go through and process that frequency value. Now, I talked about filtering the noise. One reason why you're going to want to filter the noise is if this goes too far out, then it might go to the point where it thinks it's an under frequency event and start saving data when in fact it was just noise. So that's one thing you want to consider. You may not care about that. What we're going to do is we're just going to append the data anytime it goes below the 59.1. It's just going to append the data to the file. So having more data may not be a big deal, but we're going to show how you can kind of filter that and make the false readings be a little bit less. If we've got a legitimate frequency, what we can do is we can use this very simple, it's kind of like a low-pass filter, which is kind of taking the average between the most recent reading and the previous reading and coming up with kind of an average. So it's not exactly an average. What it's doing is it's taking a weight. It's taking like 40% of the old value and 60% of the new value. And since those add up to 100%, they're going to come up with kind of an average of the old and the new. So that, for example, if the old reading is 60 hertz and the new reading is 59 hertz, it's not going to immediately jump to 59 hertz. It's going to say, well, we're going to take kind of the average and come out with something that's like in between. It's going to be like 59.4 or 59.6, something like that. So you can see one of the problems with this is it's going to, if that was a legitimate 59, it's going to take a few readings before that average works out to be that 59, because it's going to, the first time it's going to be like half of that, and the second time it's going to be the half of the next reading. So it's going to take time to get down to that reading. So you're introducing a bit of a time delay. So that's one reason why we set up the updating to a little bit faster time, to half a second, so we don't have as much of a time delay when we do this filtering. So this is up to you if you want to do. I just showed it because it's one option to minimize the number of false events. You can put in whatever you want for these multipliers. Now here, what I've done is I have subtracted 0.03 hertz. And that's from some testing I've done, and we'll show that a little bit later, where I have hooked up a multimeter that's measuring frequency of the wall outlet voltage. And I found that this application, for whatever reading, is reading a little bit high. So I just added this minus 0.03 factor that I'm going to subtract from each reading just to bring it down to match what the multimeter was showing. So yours is going to vary, but I just added that. So then I've got freak old is the previous reading. So now I am setting freak old equal to the new frequency reading. So we're going along, and each reading we're looking at the present and the past reading. So again, it's up to you whether you want to do that. I'm just showing that it's an option. Now, the next thing we have to do is calculate these minimum and maximum frequencies. And as you can imagine, it's very simple. If the latest frequency is greater than what we've already calculated for the max frequency, then replace the max frequency with the latest. If the frequency is less than the minimum, then just replace that minimum with the latest. If not, then just keep going. This last if statement is just to determine if the frequency is outside normal range. So if the frequency is less than our under frequency setting, in this case 59.9, or it's greater than the over frequency setting, or 60.1, we're going to populate this invisible label up here to say, hey, we had an under frequency event, and it's going to give us the date and the time. So that's all this does. If it's less than the under frequency value, the LBL event.text is string.format, and we said it's going to be it's an under frequency, and here's the date and here's the time. So it's the date at whatever time. And we're going to fill in date time now. We're going to use a short date string for the first one, and the time is going to be date time now, short time string, all right? And the same thing with over frequency. So the last thing we're going to do is, if we are in this over frequency or under frequency condition, then we're going to save the data and we're going to append it to a file. And if the file doesn't exist, we're going to make a new one. Using StreamWriter, we're going to call it SW, file.append text, and we're going to use that path that we defined up here in the initializing. Okay, this path right here, and yours is going to be different. StreamWriter.writeLine, and we're going to do a string.format, and we're going to put in the date time now as the first variable, then a comma, and the frequency with an F2 floating to format. So we'll show in a bit what the results are from a frequency event. But basically this just depends. So every time we have it senses that the frequency is outside the range, it's going to save the data. So the question is, do we care if we get phony data? It's just going to append it. So what we can do is, if we have an event or a bunch of events because of noisy data, all we have to do is look at the CSV file and delete anything that's bogus or not legitimate. So, it's up to you how much you want to worry about filtering and how much you want to do it in post-processing. So that's basically it. And then what we're going to do, independent of all that, we're going to come down here is we're going to update the text boxes for the frequency and frequency min and frequency max. And that's the half second timer tick. And that's all we're going to do. So that's about it for this timer tick. So the last thing we have to look at is this reset button. And like I said, one thing it's going to do, if that file exists with our path variable, then we're going to delete the file. If not, then we're not going to do anything. We're also going to reset the minimum and maximum frequencies, and our event label, which says, hey, we had a frequency event at whatever time, we're just going to zero that out again. So that's our whole application. Really very straightforward. Now what we can do is go to the bench and see our connection, and we're going to check these actual values versus a multimeter, and also show how we can use a signal generator to test this out, and also look at what happens if we do have a frequency event. Okay, so here we have an example of where we got notified. You can see up top we've got notified that there was an over-frequency event, and it's got the date and the time, 11:15 at 9:14 a.m. And our minimum and maximum frequencies are shown down here, 59.9, so it wasn't an under frequency. And a max went up to 63, and we know that's not legit. If you look down at the text, the CSV file that was generated, you can see that it was 63.59 for only one reading, so we know that was incorrect. And then 4 seconds later, we got another high reading and a 60.58. So since the power system is fairly slow acting, you imagine these big, huge generators take time to respond. So if we get like 1 or 2 readings in the space of a few seconds, we know that it's probably not legitimate. So now we've got this text file, a CSV file that's got this data. So we can choose to do whatever we want with it. We can look at this and say, yeah, that's probably not legitimate. It's only a few seconds worth of data. We could also add something in our C# application that says, you know, if we only get like 1 reading that's over or under, then just ignore it, or whatever you want for the logic. But this gives you an idea of what happens. It gives you an event indication, and it just appends that data. And you can see it was 8:30 we got one, and then 4 seconds later we got another, and then 9:14, this is like over an hour later, we got another one. So these are just random spurious noises, and we can just ignore those. So if you're going to do an application like this and build that circuit, I encourage you to verify these numbers that you get versus like a multimeter. Or as I mentioned, the other thing you can do is take a signal generator, and instead of feeding in the 12 volt sine wave from the wall outlet, or whatever voltage you're going to use, you may be able to do that with a signal generator, and that will give you a very stable and fixed frequency that you can compare your readings on this meter. So I'll leave that up to you. Otherwise, if you like any of these videos, I appreciate it if you hit the like button, subscribe, hit the bell notifications, and most of all, please let other people know that we're here so we get some viewers. Sure appreciate it. Otherwise, take care and have a really good day. Thanks.